Hi guys, welcome to lesson 13, expressions with exponents. So this is kind of taking our knowledge of expressions and combining them with yesterday's lesson on exponents. Our learning target is I can decide if expressions with exponents are equal by evaluating the expressions or by understanding what exponents mean. So let's go ahead and look at 13.1, which one doesn't belong. And usually with these, all of the expressions are equal to the same thing except one. In order to figure that out, we have to solve the expression. So let's go ahead and look at the first one. We have 2 times 2 times 2 times 2. Okay, so 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. Okay, so this first one equals 16, and so does this second one. So I think it's fair to assume that there is one other one that also equals to 16. So let's check out which one we think it'll be. We have 2 to the 4th power, and we have 4 times 2. So 2 to the 4th power, remember, means 2 times itself 4 times. And so it's going to look like this. And I'm noticing that this is the exact same thing as that right there. And so that's also going to equal 16. Now let's look at the last one and see why it doesn't work. 4 times 2 is not saying 2 4 times. It is saying, or 2 times itself 4 times. It's saying 4 plus 4. Okay, it's saying 4 2 times, or it's saying 2 plus 2 plus 2 plus 2. This is equal to 8. This is equal to 8. So 4 times 2 is the one that does not belong. Okay, so remember remember that the exponent in the little corner means to multiply it by itself that many times. It does not mean to add it. All right, let's look at 13.2. Is the equation true? So we need to decide whether each equation is true or false and explain how we know. So I would really like for you guys to try this on your own. So if possible, if you're feeling good about it, pause the video and try the problems. If not, you could do them along with me. Let's look at the first one. 2 to the 4th power, I don't know why I keep saying that. 2 to the 4th power equals 2 times 4. So 2 to the 4th power is equal to 2 times 2 times 2 times 2. And 2 times 4 is equal to 2 plus 2 plus 2 plus 2. So this side is going to equal 16, and this side is going to equal 8. And so they are not equal. So for number 1, it's going to be false. Okay. Let's look at number 2. 3 plus 3 plus 3 plus 3 plus 3 equals 3 to the 5th power. So again, 3 to the 5th power means 3 times 3 times 3 times 3 times 3. It is not going to equal the same thing as 3 plus 3 plus 3 plus 3 plus 3. If you don't believe me, go ahead and do it. 3 plus 3 plus 3 plus 3 plus 3 is going to equal 15. And 3 times 3 times 3 times 3 times 3 is going to equal 9 times 3, which is 27, times 3, which is 81, times 3, which is 243, I believe. So those are not equal. So number 2 is also false. Okay, let's look at number 3. 5 to the third power equals 5 times 5 times 5. That is exactly what 5 to the third power is telling you to do. It's telling you to multiply 5 by itself 3 times. And so this is true. Okay, number 4. 2 to the third power, or 2 cubed, that's the same thing, equals 3 squared. So let's check that out. 2 cubed is 2 times 2 times 2. And 3 squared is 3 times 3. So 2 cubed, or 2 to the third power, is going to give us 8. And 3 squared, or 3 to the second power, is going to give us 9. So they're close. They're very close, but they're not going to give us an accurate equation. False. All right. Let's look at number 5. 16 to the first power is just 16 equals 8 squared, or 8 times 8. So 8 times 8 is not 16. That would be 8 times 2. And so this one is false. Okay, number 6. 1/2 times 1/2 times 1/2 times 1/2 equals 4 times 1/2. Well, let's go ahead and do that one. When you're multiplying fractions, you multiply across. So 1 times 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8, times 2 is 16. So you have 1/16. Now 4 times 1/2, you have to make that 4 over 1. 4 times 1 is 4, 2 times 1 is 2, 4 divided by 2 is 2. So 1/16 does not equal 2. That is false. Okay, next one. 1/2 to the fourth power equals 1/8. Okay, so 1/2 to the fourth power is actually exactly what we did right here. We did 1/2 times itself 4 times, and we got 1/16. 1/16 is not 1/8, so this is false. That was convenient. We already did that one. All right. 8 squared, or 8 to the second power, equals 4 cubed. Let's check it out. We have 8 times 8, and we have 4 times 4 times 4. Okay. 8 times 8 is 64. And 4 times 4 is 16. 16 times 3 is equal to 48. So 48 does not equal 64, so this is also false. All right, the only true one in this entire thing was number 3. If you're confused about why, please let me know. We'll go over it. Let's go ahead and move on to 13.3. Okay. In each list, find expressions that are equivalent to each other and explain to your partner why they are equivalent. Okay, so we don't have a partner. So you just have to explain to yourself, I guess. Anyway, we don't have partners unless you're Ashley and Abby, or you're working with a parent maybe. Just try your best to solve the problems and do it on your own. So we're looking for equivalent expressions in each problem. So for number 1, we have 5 times 5, which I can already know is 5 squared. And so I can see a pair right here. Let's look at 2 to the 5th power and 2 times 5. 2 to the 5th power is 2 times 2 times 2 times 2 times 2. And 2 times 5 is 10. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So these do not have a pair. All right, number 2. We have 4 cubed, 3 to the 4th power, 4 times 4 times 4, and 4 plus 4 plus 4. So I'm going to take 4 cubed, and I'm just going to write out what that is going to equal. Because it's 4 times itself 3 times, I'm going to write out what 3 to the 4th power is equal. Alrighty, so here we can see we have a perfect match with A and with C. Now let's look at C and D. B and D. On B, we have 3 times 3, which is 9, times 3, which is 27, times 3, which is 81, and 4 plus 4 is 8, plus 4 is 12. So these do not match. Okay. Number 3. 6 plus 6 plus 6. This is equal to 18. 6 to the 3rd power is 6 times 6 times 6, which is 36 times 6, which I have to do this way because I can't do that in my head. $252. So far we don't have any matches. This is 3 to the 6th power, or 3 times 3 times 3 times 3 times 3 times 3. And this is 3 times 6, which is 18. So I see that 6 plus 6 plus 6 and 3 times 6 match. Let's go ahead and do this one. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, times 3 is 729. So those do not match. Okay. If you're feeling pretty good about this, go ahead and shut off this video, do the rest on your own, or pause the video, try them, and then see if you got the right answers. I really think if you're following along on the first 3, you definitely can figure out the next. Otherwise, just keep going. So, 11 to the 5th power. I can rewrite that as 11 times 11 times 11 times 11 times 11, which is the same as the one below it. 11 times 5 is not going to give me the same answer because that is 11 plus 11 plus 11 plus 11 plus 11. Remember, multiplication, standard multiplication, is just repeated addition. 5 to the 11th power is going to give us 5 times 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 5. I think that's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that is not going to give us the same answer, and so that does not work. Okay, don't let the fractions scare you. Let's check it out. This right here, A, is 1/5 times itself 3 times, which can be rewritten as 1/5 to the 3rd power. I see that down here. The parentheses are just so that you don't get confused between the fraction and the exponent. Let's see. 1/15, let's see if that makes any sense. So when we have 1/5 times 1/5 times 1/5, we're doing 1 times 1 times 1, and we get 1. And 5 times 5, which is 25, times 5 is going to get us 125. So that is not the same thing as this. However, it is the same thing as this. So that's going to give us the same answer. So that one had 3. All right, last one. 5 thirds squared. Okay, so we have 5 thirds times 5 thirds. And then we have 3/5 squared. That's 3/5 times 3/5. So let's solve those. 5 times 5 is 25. 3 times 3 is 9. Here we have 3 times 3 is 9 over 25. So that is not the same fraction, 25 over 9 and 9 over 25. They're actually inverse, so they're flipped, but they're not the same amount. Let's look at 10 over 6. So 10 over 6 is the same thing as 1 and 4/6, or 1 and 2/3. Okay. D is 25/9. So we know that D and we know that A are the same. Let's go ahead and see if we can reduce 9/25 to anything. So 9/25 it can be, we can see if they have any shared factors, which the factors of 9 are 1, 9, and 3. And 25 is just 1, 5, and 25. So this actually can't be reduced any further. And so the answer is just A and D for that one. Okay, so I'm just going to go through this little sliver of the lesson summary with you guys. It says, when working with exponents, the bases don't always have to be whole numbers. They can be other kinds of numbers like fractions, decimals, and even variables. For example, we can use exponents in the following way. And it gives us this example of 2/3 to the 4th power as being 2/3 times 2/3 times 2/3 times 2/3. And it also gives us a decimal example, 1.7 to the 3rd power, which is 1.7 times 1.7 times 1.7. And then we have x to the 5th, which is x times x times x times x times x. Okay, I hope this lesson made sense to you guys. The target was I can decide if the expressions with exponents are equal by evaluating the expressions or by understanding what exponents mean. Yeah, so I hope you had a chance to self-rate your understanding, and I hope you're feeling good about it.